looking at copper displacing silver. So let's start with the reaction, identifying who are involved. So we have the copper, then we have silver, nitrate, then we have the cupric nitrate, copper 2 nitrate, if not cupric nitrate, and we have silver. So is it balanced? Let's have a look at it. So we have copper, silver, nitrate, and silver. So listing all the reactants and the product at the top, and then the atoms along the first column. Then mapping it out. This is 1, and in AgNO3 we have 1 Ag, 1 N, and O3. So basically oxygen is 3. And CuNO3 twice we have 1. None of this. There are 2 nitrogen, and oxygen is 6. In Ag there is 1 Ag. So we'll start off with oxygen. On the left hand side this is 3, and so this is 6, so we need to multiply with 2. For the oxygen to be 2, we need this entire thing to be 2. Only then this will become 6, is it not? If AgNO3 is not multiplied with 2, if there are not a pair of AgNO3, then this cannot be 2. Because we multiply this with 2, by default we have to multiply Ag and NO, N also to be 2. N is balanced, Ag is not, so we'll multiply this with 2. And copper is balanced. Copper is 1 and 1, Ag is 2 and 2, nitrogen is also 2 and 2, and oxygen is 6 and 6. And it's balanced, as simple as that. Right guys, so we have Cu, which is solid. Obviously when dipped in, see always this is dipped, so this is always aqueous. So this is a common pattern. Then there is nothing, no catalyst needed. And we have 2 Ag, which is solid. And this is aqueous actually. And that's that. Now, how do you get to know that the reaction has happened? So color change in solution. So initially, the colorless silver nitrate solution will turn blue. So again, copper, you can see the same pattern. It's nothing much. So we have from colorless to blue as a copper nitrate is formed. So basically from AgNO3 to we have CuNO3 twice. So that's why it became from colorless to color. Then formation of solid. Right. So a grayish white solid metallic silver will be precipitating out of the solution or deposited on the surface of the copper metal. So basically we're looking at a grayish white solid that will appear in the solution basically. So this will either precipitate or deposit right on the surface of the I'll just write copper metal. And finally, yes, here too we have heat generated. So you can see it's the same pattern. That's basically your exothermic reaction. And why is this happening? Quite simple. You have Cu above Ag in reactivity series, as simple as that. And you have Cu comma AgNO3. They are at higher potential, higher energy potential than your Ag and Cu and O3 twice, which is at lower. So there is difference in energy. And how will this difference in energy appear as? It will appear as heat. As simple as that. Again, guys, it's the same pattern again and again, again and again. Only thing that will change is, yes, the names. Names two are actually kind of similar. And balancing equation.